Hey class, this is the first lesson of the surface area and volume unit, and today is 11-2. In the textbook we're going to be doing the surface areas of prisms and cylinders. Just a quick summary of this whole unit. We're going to be doing how to find the surface area and volumes for all but one of the shapes over on the right. I'm sure you guys can probably guess which of those shapes we're not going to be able to calculate the surface area and volume for. But we are going to cover prisms, cylinders, which actually aren't pictured here, cones and pyramids, cubes, which are actually just a special type of prism, and finally spheres, which look like they might be kind of complicated but are actually really simple. So the things you'll need this unit are the homework and mastery quiz list, or you can just get everything off Google Classroom, and of course a formula sheet for surface area and volume, which I'll be passing out in class. So, in the first thing we need to look at is what is a prism. So when we talk about a prism, we're basically talking about any shape that looks something like this, where we have a base on each side, and they're connected by these what we call lateral faces. So the lateral faces connect the bases. For it to be a prism, the two bases need to be the same. So notice here that we have like a pentagon on the top and a congruent pentagon on the bottom. In this big shape, this is, by the way, an animation in your textbook. You can actually move it around and stuff. It's kind of cool. We have a hexagon on one side, and we have a congruent hexagon on the other side. That's kind of important. Notice that a prism can have bases of any shape. So we have like a pentagonal prism up here, a hexagonal prism down here, a triangular prism over here, and of course our favorite is going to be the rectangular prism. At least that's my favorite. Those are kind of the easiest to deal with. We can have a right prism, and these are going to be most of the ones that we deal with, where the base is perpendicular to the height. So this is kind of, I think, what you would think of as like just a box, right, where everything's a right angle. This is especially true in the case of a rectangular prism. That's like a really easy to think of as a cardboard box, like something Amazon might send you. Over here, though, we have the oblique prisms. So what's happening here is that the base isn't perpendicular to the height. So notice that we've seen triangles like this where the height isn't one of the sides. It's actually, we sort of can see it best if we set it off to the side a little bit. So this height is still the height between the bases. It's just that the sides are slanted. So I don't know, this would be kind of a bad box to ship something in, I think. But the height is actually outside the object, or we could think of it as being inside, but it's not going to be one of these slanty sides because the bases are actually closer together than that. Okay, so the first thing we're going to look at is using a net to find the surface area of a prism. We haven't talked about nets a whole lot, but I want you guys to imagine that we kind of take this whole box and we just unfold it. So hopefully everyone can imagine like we've taken this whole box, we've just kind of broken it up into each of the different faces. So what we're going to do is calculate the surface area now of this box. So one of the faces, notice, is 5 long and 4 wide. We can find the area of that rectangle, right? We do 5 times 4. Notice we're doing that here. And then we do, there's going to be another one where it's still 5 tall, but now it's 3 wide. So we're going to do 5 times 3. Then if we go to the back of this thing, it's 5 tall, 4 wide, 5 times 4. And then if we look at this side over here, that'll be 5 tall, 3 wide. So 5 times 3. Then we got to deal with the two bases, right? So 4 times 3. And again on top, 4 times 3. So we're going to wind up with 20 plus 15 plus 20 plus 15 plus 12 plus 12. That's 94. We're going to find a more efficient way to do this in a second. Don't worry. Here's that more efficient way. So we're going to talk about two kinds of area here. First of all, we're going to talk about lateral area. Now the lateral area I want you guys to think about is the kind of side area of this thing. So it could include this side, this back side over here that's kind of on the opposite side of the box, and this side over here. What it's not going to include is the top and the bottom of the box. So those would not be included in lateral area. Lateral means side, so the top and bottom are not going to be included in the side area, but the top and bottom are going to be included in the surface area, which is the sum of all the surfaces of this box. So the lateral area of a right prism is actually super easy to find. It's just perimeter times height. When we talk about perimeter here, we are talking about the perimeter of a base. Okay? Then the surface area of a right prism is going to be the sum of the lateral area, which we can find using this formula, and the area of the two bases, the one on the bottom and the one on the top. Let's see an example of this in action. So we'd like to find the surface area of the prism shown. Notice this is a triangular prism. That's going to make things a little more complicated, but not hugely more complicated. I also want to point out this is a right triangle. I'm looking at this angle here. That's also going to be important. First thing we need to do right off the bat is find the perimeter of the base. Notice we've got 3 plus 4 plus, oh, we don't know this side here. But we can use the fact that this is a right triangle to set up our a squared plus b squared equals c squared. And if we do that through, we're going to find 3 squared plus 4 squared is 25, and the square root of 25 is 5. So this last side is going to be 5, which means our perimeter is 3 plus 4 plus 5 gives us 12. Now we got to find the lateral area. Remember, lateral area equals perimeter of the base times the height. So we got this 12 up here. We're going to multiply by the height. That's going to give us 12 times 6 is 72. Okay, so now we've got the lateral area, which is the area of this side over here, and this side in the front. What we've got to do next is find the area of the base. So what we're going to do that is simply use the formula for the area of a triangle. Notice the bases are triangles. So we're doing 3 times 4 divided by 2. 3 times 4 times half, and that gives us 6. Notice 3 times 4, that's 12. Divide by 2, that's 6. Step 4, we need to find the surface area of the entire prism. Remember, we found the lateral area, but that only gives us the side areas, doesn't include the top or the bottom. So we've got to add now twice the area of the base. So if we look at this, we've got 72 as the lateral area, 6 as the base area. Plug that in, we've got 72 plus 2 times 6, and that should give us 84 centimeters squared. Now notice, surface area is still an area calculation, so we're still going to wind up with centimeters squared. Later in this unit, we will see volumes, and those are going to be centimeters cubed, but we're not there yet. We're just on surface area. Surface area is going to be centimeters squared, or anything squared. Okay, let's talk about cylinders for a second. I don't want you guys to think about cylinders as completely different from prisms, because they're really not. Notice that the only difference is now the base is a circle. We still have a base at either end. The bases are still the same size. They're congruent, same size and shape. And the height is the other dimension here. Again, we have right cylinders, meaning the height is perpendicular to the base. And we have oblique cylinders where they're kind of slanted. But same idea applies. We have a base. We could find the base area here using the area of a circle formula, pi r squared. We have a height. So let's see how this all clicks together with the formulas. The only difference here is that instead of perimeter, we're going to talk about circumference. Now I want you guys to imagine, okay, you can think about this almost like if you took a toilet paper roll, right? And you cut it right in a straight line right down the toilet paper roll. And then you kind of folded that out. The shape that you'd get would actually be a rectangle. Right? So they're kind of showing like mostly curling this all the way out. And by the way, this is another animation in the textbook, which I highly recommend you check out. So if we rolled this out, we'd get a rectangle as the lateral area, which would have a length of 2 pi r. That would be the circumference of the circle, 2 pi r. That's almost like the perimeter from the earlier formula. And we're multiplying that by the height of the cylinder. So notice the lateral area, which was earlier perimeter times height, is still going to be perimeter times height. It's just now we have a better formula for perimeter. So the circumference, the area of this whole blue thing is going to be 2 pi r h. Let's see if we can apply that. Oh, we'll apply it in a second, sorry. So first of all, we just want to review. Lateral area equals 2 pi r(h), right? Or pi dh. Notice that d here is taking the place of 2 r's because the diameter is twice the radius. The surface area is going to be the lateral area plus, again, same as with the prism, 2 bases. Or the surface area is going to be equal to 2 pi r(h), that's this formula up here, plus 2 pi r squared, which is 2 area of the circles. So notice this formula not actually that complicated when you really get into it. The only things that ever change in it are r, the radius of the circle, and h, the height of the cylinder. So let's try to put this into practice. Okay, the radius of the base of a cylinder is 4 inches, so notice radius 4, and its height is 6 inches, so h is 6. What's the surface area? So we're finding surface area, not lateral area, of the cylinder in terms of pi. So remember what that means. We're going to leave the pi in the answer. Notice we have pi's in all these answers. So first of all, we're using this formula for the surface area of a cylinder. Surface area equals lateral area plus 2 bases. That's 2 pi rh plus 2 pi r squared. Now we plug in the numbers. So it's going to be 2 pi 4 times 6 plus 2 pi 4 squared. Now I can already see this is going to give us 48 over here and 32 over here. So we're going to get 48 pi plus 32 pi, which I think is going to give us 80. And indeed it does. So the surface area of the cylinder is 80 pi inches squared, which would be answer choice C. Let's do another one. This is a little more applied, I think. Notice, so you are using the cylindrical stencil roller below to paint patterns on your floor. What area does the roller cover in one full turn? So you can imagine this thing going like all the way around. When you kind of turned it once, how much area have you covered? So they gave us, now be careful here, they didn't give us a radius, right? They gave us a diameter. So we're going to try to use the formula that involves diameter. They also told us the height. Notice that that 6 inches is the height of the cylinder and this 2.5 is the diameter. So again, we've got lateral area, and we are going to be finding lateral area here because the area of the bases doesn't really factor into this. Notice that the sides of the cylinder are never going to paint the floor. We've got a height of 6 inches and a diameter of 2.5. So let's look at our formula. Okay, lateral area is pi times d times h. So we do pi times 2.5 times 6. That gives us 15 pi. Now I would just leave my answer right there. But the book does say that's approximately 47.1 inches squared. So in one full turn, the stencil roller does cover about 47.1 inches squared. Now, if you are confused at all about why we used lateral area and not surface area in this problem, I encourage you to think about why we wouldn't want to include this in the area that the roller paints. But also, I would follow up maybe with a question to your classmates or to me. So, your homework tonight is going to be number 87. This one should be posted on the Google Classroom by now. And I want you guys to do page 1606, numbers 11 and 15. Page 1607, number 18. And you should also check out the 11.3 slides for next time. Notice again, just 3 problems, so it shouldn't take you too long. And there are some other exercises there if you want extra practice. Good luck!